Hello everyone, I hope you all are fine. My name is Shubham and today we'll be discussing about some numericals on the topics that we have done in last 2 days, that is resistances in series and parallel. So for that I would suggest all of you to open your NCERT notebooks and one rough notebook with you or your fair notebook with you, whatever you want. So this is the first topic that we covered in the NCERT, resistances in series, and after covering this topic, this was the final formula that we got. You can see in your notebooks or you can see in your books that we talked about this potential difference being the sum of potential difference across the different resistors, that is V is equal to V1 plus V2 plus V3 in case of series combination. And after applying the Ohm's law, then this was the final expression. This was the final expression for resistance in series, where V1 was I into R1, V2 was I into R2, and V3 was I into R3 by Ohm's law. These were the different potential difference due to across the all three resistors, and this was the final formula that we got for resistance in series, that is RS or R series is equal to R1 plus R2 plus R3. On this part, we'll be starting with this numerical that we have. It says an electric lamp whose resistance is 20 ohm. This is an electric lamp that has been given to us in the figure, and the resistance of this electric lamp is 20 ohm and a conductor of 4 ohm resistance. This is the conductor. So this is the conductor. Let us name this as well so that you can get better idea for this. We'll name it as conductor. So this is your conductor and this is your lamp that we have. The diagram, I hope it is clear to you. Next, it says are connected to a 6 volt battery. Now this is the battery. 6 volt battery has been given to us, and calculate the total resistance of the circuit. This is the first part, that we have to calculate the total resistance of the circuit, and second is the current through the circuit, and we have to find the current as well. Means the current will start from positive terminal of the battery and it will ultimately move to the negative terminal, and this is the key that we talked about yesterday. I hope you all remember I told you that this is the key. While tapping this key, we complete the circuit and the current starts flowing. And this is the emitter. This part is the emitter, and emitter is something which measures the amount of current flowing in the circuit, and emitter is always connected in series. You all must remember this thing, that emitter is always connected in series and voltmeter is connected in parallel. So let's continue with the first part of this question. First part says that the total resistance of the circuit we have to find, and in order to find the total resistance of the circuit, we can clearly notice that this conductor and this bulb, let us name this as well. This is the bulb that has been connected in series with the resistance. So this conductor and this bulb are connected in series, and we'll simply apply the formula for resistance in series. The resistance of electric lamp is R1 is equal to 20 ohm, and resistance of conductor is also given to us. So this is 20 ohm and this is 4 ohm. Since both of them are connected in series, so total resistance in the circuit will be R is equal to R1 plus R2, where we have applied this same formula that we derived earlier in the first lecture. This formula, resistance in series is given by this RS is equal to R1 plus R2 plus R3. In this case, we have only two resistors, so that is why we have taken this as 20 plus 4, that is 24. And one more thing we have to find out in the second part. Second part is the current flowing through the circuit. Now when we have to calculate the current flowing through the circuit, you all must remember how to calculate the value for current, and this is the expression for Ohm's law. Ohm's law suggests that V is equal to I into R, means potential difference is equal to the product of current and resistance. We have already calculated the value for resistance, that is 24 ohm. This is the total resistance of the circuit, and we also have been given the potential difference of the circuit or the voltage of the circuit, which is given by this battery. let us name this as well. This is the battery of the circuit. This is the battery that I am talking about. So the EMF of this battery, or the potential difference of this battery, is 6 volts. So by using this formula, V is equal to 6 volt, I is equal to V by R. So 6 by 24, this case 6 by 24, 24 is the total resistance and 6 is the voltage. So when we will calculate this 6 by 24, it will come out to be 1 by 4, and 1 by 4, after dividing this, we have written it as 0.25 ampere. So this is the second part of the question. This is the second part in which we have to calculate the value for current. Now let's move to the third part of the question. Third part suggests that we have to calculate the potential difference across the electric lamp. This thing, we have to calculate the potential difference across the electric lamp and the conductor. Now we can clearly see that this 6 volt would be divided into this conductor and this bulb. Means whatever amount of potential difference we have, 6 volt, it will be divided in this conductor and in this bulb. And we also discussed in the first video where we discussed the resistances in series, that whenever we have to calculate the value for potential difference across different resistors, in that case we'll take the current as same, because you can see in the figure the I current flows through the circuit, and I current would be having same value when this will be flowing through this circuit. So same amount of current will be flowing through these two. So when we will calculate the value for potential difference across these two, we have to calculate by using the Ohm's law only. It says applying the Ohm's law to the electric lamp and conductor separately. This point we need to take care that we have to apply the Ohm's law separately in different conductors. We get potential difference across the electric lamp, that is V1 is equal to 20 into 0.25, where 20 is the resistance and 0.25 is the current that is flowing through the circuit. As you can see that we have already calculated the value for current in the circuit, which is coming out to be 0.25 ampere. Current would be same in both the cases, and after calculating the value for current, we'll simply apply Ohm's law. Let us write the formula as well. Ohm's law states that V is equal to I into R. So this is the formula for Ohm's law. V is equal to I into R. When we will apply this formula, in this case value of current, this I is 25, so this is the value for current, and R is 20, and we have not put the value for R as 24 ohm because we are trying to calculate the potential difference across the resistor number, across the bulb which is having the resistance 20 ohm. So this is the electric lamp 20 ohm, so it will be the potential difference across the 20 ohm resistor. V1 is equal to I into R1. So means this 6 volt potential would be divided into two parts. One part of this would be divided across the lamp, which we have already calculated, and it is coming out to be 5 volt. So means out of 6, the 5 volt potential difference would be across the lamp, and let us try to calculate the remaining potential difference across the conductor by using the same formula, that is V is equal to again I into R. And when we will try to calculate this formula by using V is equal to I into R, for that I would be same, that is 0.25 ampere, and voltage would be, voltage we have to calculate, I is 0.25 ampere and resistance would be 4 ohm. This is the resistance 4 ohm. So 0.25 into 4 comes out to be 1 volt. So we can say that the 6 volt potential has been divided across two things, this 5 ohm and this 1 ohm. Of course this 5 ohm has been divided across the electric lamp. Let us write it here as well. This 5 ohm has been divided across the electric lamp, and this 1 ohm has been divided across the conductor. So we can clearly see that whenever we try to connect these two resistances in series, obviously it will have two potential difference and those two potential difference can be calculated by these expressions. So I hope this is clear to you. This was the third part of the question. Let's revisit the question once again. It was to calculate the potential difference across the lamp and the conductor, and the lamp is having the potential difference of 5 volt and conductor is having the potential difference of 1 volt. This part is an important part, and this is important from the point of view of conceptual part. If we have to take care into consideration, what this suggests is, suppose that we like to replace the series combination of the lamp and conductor by a single equivalent resistance. You might remember that we talked about the equivalent resistances in series in detail. What this equivalent resistance in series means, if we have to remove these two resistors, let us say this conductor is resistor number 1 and this bulb is resistor number 2. If we have to remove all these, if we have to remove these two resistors and we have to connect a single resistor instead of them, then single resistance should have the value equivalent to the, that single resistor should have the value equal to the equivalent resistor. So I'll write it here as well for your reference, that single resistor should have, you can note it down in your notebooks as well if you want to note it down, should have the value as the equivalent resistance. So this is the important point that we have to calculate, or that we have to note rather. Whatever resistance is to be applied by removing these two resistors, that is known as the equivalent resistance or equivalent resistor. So this is the thing that you have to take care. So kindly note these points, and we'll see you in next video. Take care.